Good evening, everyone. It is once again Ted the Speed Learner, and I would like for you guys to bear with me because we are going to cover the topic of linear interpolation. What is linear interpolation? Well, first of all, why would you need linear interpolation? Because in a future video, I'm going to be covering Bezier curves. Yes, I finally found out how to pronounce this dang thing. Bezier curves, it's French, obviously. And you're going to use linear interpolation in your Bezier curves. That's why you have to learn this. But there are other applications for this as well. Now, let me give you a simpler application, then we can build up to the more complex. Okay. Let's say that somebody gives you a recipe for a cake. And if you follow the recipe to the decimal point, you will be able to bake a cake that's 12 inches in diameter. Okay. That will be represented here. And actually what I should have done, and I'm going to go ahead and do this, I'm going to switch this. This should be 1 here, and this should be 1 as well. As you know from previous videos, these are subscripts. And if you don't know that, you need to review my mathematics videos and you can learn that for yourself. Okay. Now then, let's say that you decide instead of baking a 12-inch diameter cake, and yes, you should know what diameter is, you should know what radius is, all that stuff should be known to you by now. If you don't know that, go back to my mathematics videos and you can learn this for yourself. Okay. Now then, let's say you decide instead of baking a 12-inch round cake, it would be a 12-inch diameter cake, okay, you decide instead to bake a 24-inch diameter cake. Well, that's real simple. You just double the ingredients of the recipe, and you'll be able to make a 24-inch diameter cake. The problem comes when you have to bake an 18-inch diameter cake. Now what are you going to do? Well, we're going to call the coordinates of this x and y. Okay? This point represents the ingredients for a 12-inch diameter cake. This point represents the ingredients for a 24-inch diameter cake. Specifically, we're going to focus on one of the ingredients, which is flour. Okay? We're going to say that you need so much flour for the 12-inch diameter cake, so much flour for the 24-inch diameter cake. Now, how much flour are you going to need for that 18-inch diameter cake? Well, no. Okay. How are we going to figure this one out? Well, we're going to build up a ratio. That's how we're going to figure this one out. And draw this out real quick, because I'm going to erase this here in just a second, and then I'll go ahead and show you the rest of this. So, go ahead, freeze the frame, draw this out. Okay. Let's erase that real quick. Okay. Now what you're going to have, we know that the distance of that line we just had up here a minute ago, and I'm sure you've got it right in front of you right now. The distance of that line is D, not D, I'm sorry, forget D. It's actually X, well that's a terrible X. Let's try that again, shall we? It's actually X2 minus X1. Now remember that these are subscripts, not superscripts. So we're not squaring anything. We're just using these as subscripts. So this would equal the distance of the line. I'll just put DIST as an abbreviation. So if you take the x-coordinate here and you subtract the x-coordinate here, you'll get the x-coordinate distance of the line. You can do the same thing with the y-coordinates as you did with this. Okay? Now then, Alright, now you not only have to find the x-coordinate, but you also have to find the y-coordinate. It's very important. So what's going to happen is you're going to have a line chart. Okay, this would be the size of your cake, and this would be the flour ingredient. The more flour you have, the bigger the cake is going to be. So if you have this much flour, you're going to have this size cake. If you're going to have that much flour, you're going to have that size cake, so on and so forth. Getting the picture? That's why we had that great big line. Ta-da. Or actually, in this case, we shouldn't draw the line down. More likely, we should draw the line up. Actually, it should go something like this. Because the more flour you have, the bigger the cake will be. Same difference. I mean, whether you draw the line this way or that way, it doesn't make any... It makes a difference with your line chart, but it doesn't make a difference in the computations as far as that's concerned. Alright. So, you get the picture. Anyway, if you don't, I'll explain it further. No problem. Anyway, so we're going to set up a ratio. We're going to have x2 minus x1, both subscripts. And then we're going to have down here, and yes, my voice does tend to crack every once in a while. We have y2, y1. Okay, now what do we put up on the top here? Well, we have to figure out the distance between the middle point. Remember, we had 3 points in the line. The first two were on the outer edges of the line, and the third one was right in the middle. Okay, now we have to figure out the distance of the middle line. And then what you're going to do is you're going to figure out the distance between that middle point and one of the 2 points on the line. So we're going to have x minus x1. Boy, that looked ugly. Where is my... Okay, there we go. That looked terrible. Let's try that again. And then we have... Isn't that a terrible Y? I can't draw for nothing. Let's try that again. So now we have y minus y1. Now we can simplify all this. Okay? Now then, how do we simplify all this? Well, first of all, we have to get the first side of the equation. What we're going to do is we're going to do this. Alright. X minus x. Oh, holy cow, that was terrible too. x1. And I know I usually draw these fancy little ones. I could draw that here if you want. I do that because I'm a data processor and I have a nasty habit of doing that. So anyway, you have x minus x1 equaling, first of all, this didn't change. However, we're now going to multiply it by we're going to multiply both sides of this equation by x2 minus x1. That's how we get all that. Now, we still have to get rid of this figure right here because this is the number we actually need. So what are we going to do here? Well, we're going to do this. X is going... Oh, that's a horrible X. Okay, so I'm not an artist. X equals x1, and you say, well, gee, if it's subtracted here, what you're going to do is you're going to add x1 to both sides. That's what you're going to do. Now, you're going to add this. This is y minus y1, y2 minus y1. And then you're going to, of course, multiply that one. And that's what you're going to have. Now, let me make sure that you're getting all this. Yep, you are. Very good. But in the end, that's what you're going to have. You're going to have x equaling x1 plus this ratio right here, and all this is going to be multiplied by that right there. And that's how you get linear interpolation. Whew. Wasn't that just fancy? Now, I will discuss this further in one of my future HTML lessons, because we're going to be covering Bezier curves. And the way you develop Bezier curves is you're going to have two lines, basically. Okay, here's line 1, here's line 2, and you're going to have this other line that's going to come across here. And then you're going to use linear interpolation to draw a curve from here to there, like that. And the coordinates of this curved line will be based on the linear interpolation of this line and this line. Like I said, I'll go into this a little bit further when I cover that HTML lesson. So you need the linear interpolation of this line and the linear interpolation of this line to create the Bezier curve of this. And when you have it drawn like this, this is called a quadratic Bezier curve. Okay? There's also a cubic Bezier curve, and the difference between the quadratic and the cubic is that instead of having one point up here, you have 2 points instead. And these 2 points then control the curve. They control the curve. They control how far out it goes. They control how wide it is. Get the picture? Alright. So anyway, like I said, there's a quadratic Bezier curve and there is a cubic Bezier curve. And I will introduce both to you in a future video. So, anyway, hopefully you learned a lot. I know this was kind of boring, but there you go. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.